Dear students, from the topic differential equation, today we are going to discuss the applications of differential equation, in which we will solve some examples related to the applications. First of all, you note that important steps to solve the question related to applications of differential equation. First step that we have to do is form the differential equation using given condition. Then next step is find the general solution, that is GS, of a differential equation. Then third one is use initial condition to get the value of C. Value of C means integration constant, and then find the particular solution, means after getting the value of C you will get the particular solution of that differential equation. Then fourth one, use given condition to get the value of K, where K is proportionality constant, and put that value of K in the particular solution. And after getting the value of K as well as value of C, use that equation which is obtained by this procedure to find out the required value. So by using all these steps, we have to solve some questions from the exercise. So let us see. Now see the question here. The rate of growth of bacteria is proportional to the number present. Okay, if initially there were 1000 bacteria and the number doubles in 1 hour, then find the number of bacteria after 5/2 hours. And here the given value is root 2 is equal to 1.414. Now we will follow that all previous steps that we have discussed already, and then we will try to solve this example. Okay, so let us see here how will you solve this. So in answer, first of all I will write here the number of bacteria, the rate of growth of bacteria is proportional to the number present. So first of all I will consider that let X be the number of bacteria. Let X be the number of bacteria at a time t. Okay, first of all we have to consider X be the number of bacteria at time t. Now rate of growth of bacteria means it is the rate of increase of bacteria is proportional to the number present. Now rate of increase or rate of growth, mathematically it is denoted by dx by dt. So rate of growth of bacteria, which is equal to, mathematically it will be dx by dt. Okay, now it is given that this rate of growth of bacteria, that is dx by dt, is directly proportional to the number present. See here, number present. Now number present is x, so we get dx by dt is directly proportional to x, and hence by considering the proportionality constant we get dx by dt is equal to k into x. So by given condition here we get the differential equation. So this is the formation of the differential equation from given condition. As earlier we have discussed all the steps. So here we get dx by dt is equal to k into x, where x is a variable and t is also variable. Now solve this differential equation by using variable separable method. Now I will separate the variables here. So keep dx here, then it will be k into x into dt. So the positions of x and t are fixed. Now you have to transfer this x to the left hand side, and hence we get 1 upon x dx is equal to k into dt. So this is the variable separable form. Variable separable form. Remember, after getting the differential equation from the given condition, we use the variable separable form to get the general solution of this given differential equation. So now integrating both sides. So next step is integrating both sides. Now see what will you get here. So it will be integration of 1 upon x dx is equal to integration of k into dt. Now all of you know that integration of 1 upon x is log x, okay, is equal to, here k is constant, so k keep as it is, into integration of 1 with respect to t is t plus c, and this is called as the general solution of the given differential equation. So you can write this is general solution of the differential equation. So see this carefully. Okay, log x is equal to kt plus c. Now next step is what? We have to use the initial condition here. Now initially, always remember, initially, that is when t is equal to 0, what is the value of x, means number of bacteria? In this question it is given that if initially there were 1000 bacteria, so when t is equal to 0, x is equal to 1000. Now if you put this value in the given or in the obtained general solution of differential equation, then what will you get? We get log of 1000 is equal to k into 0 plus c. Hence we get the value of c here. So c is equal to log of 1000. So we have mentioned that after using initial condition, always you will get the value of c here. So here c is equal to log of 1000. Now put this value of c in the general solution. So general solution becomes particular solution. So we get log x is equal to kt plus log of 1000. Now this will be a particular solution. Now just we modify this. If you keep this log of 1000 to the left hand side, then what will you get? We get log x minus log of 1000 is equal to k into t. That means by logarithmic rule, this can be written as log of x upon 1000 is equal to k into t. You can say that this is the particular solution of the differential equation. After getting the value of c, we get the particular solution. Now use the given condition. Next step is we have to use the given condition. So what is given here? We have given that when t is equal to 1 hour, when t is equal to 1 hour, the value or number of bacteria will double. So originally it was 1000. So after 1 hour it will be 2 into 1000, that is equal to 2000. So value of x will be 2000. So if you put this value in this particular solution, then what will you get? See here, next step, you will get log of 2000 upon 1000 is equal to k into 1. Now by which you will get the value of k. So that implies k is equal to log 2. See here. So we get the value of k. So as we discuss in that all the steps, that after getting the value of c by using initial condition, then by using given condition we get the value of k. Now rewrite the equation. So we get the equation like this. After getting the value of k, we get the equation, that is log of x upon 1000 is equal to k into t, that means log 2 into t. Okay, so now this is very important equation that we have obtained here. Say this is equation number 1. So first of all we form the differential equation by using given condition, then we use the variable separable method to get the general solution of the differential equation. As you get the general solution, use the initial condition by which you will get the value of c, and after getting the value of c you will get the particular solution of the differential equation. And then using given condition, that is when t is equal to 1, x is equal to 2000, we get the value of k, that is equal to log 2, and hence the final equation after getting the value of k and c, we get log of x upon 1000 is equal to log 2 into t, and say this is equation number 1. Now come to the main question, that what we have to find out. We have to find out, now after getting this equation, we have to find out the value of x or number of bacteria. We have to find out x when value of t is given, that is t is equal to 5/2 hours. Okay, so if you put this value, given value of t is equal to 5/2 in equation number 1, so we get, hence we get log of x upon 1000 is equal to t means 5/2 into log 2. Now solve this equation to obtain the value of x. That will be our final answer. So for that, here we will compare log on both sides. So for that we have to modify the equation like this. Keep log of x upon 1000 as it is, and here by logarithmic rule this 5/2 into log 2 can be written as log of 2 raised to 5/2. Okay, now direct comparison between the logarithmic term is possible here. So by comparing both sides, we get x upon 1000 is equal to 2 raised to 5/2. Now 2 raised to 5/2 we have to solve here. So what is 2 raised to 5/2? Actually it is root 2 raised to 5. Okay, so x upon 1000 means root 2 raised to 5. Now if you see here for the further calculation, then root 2 raised to 5 is nothing but 4 root 2, means root 2 into root 2 into root 2 into root 2 into root 2, means 5 times the multiplication of root 2, and hence you will get x upon 1000 is equal to 4 root 2 is equal to 4 root 2. Now value of root 2 is given to you, that is 1.414. okay, now if you multiply this, then what will you get? Then you will get 5.656, and left hand side is x upon 1000. Now what will be the value of x? So x is equal to 5.656 into 1000, that is equal to 5656. Okay, so value of x will be 5656. So the number of bacteria, so you can write the number of bacteria after 5/2 hours is equal to 5656. So this is the final answer. Number of bacteria after 5 by 2 hours is equal to 5656. Okay. So see here, we have to follow the steps that already we have discussed. We have to form the differential equation. Then by using variable separable form, we have to obtain the general solution. Then using initial condition, we will get the value of C, by which you will get the particular solution. And after getting the particular solution, when we use the given condition, that is here in this case, when t is equal to 1, x is equal to 2000, by which you will get the value of k. And if you put that value of k in that equation, then you will get the equation which is useful to obtain the required answer. Okay, so these are the main steps related to this type of question. Okay, so see all the steps, all important steps to solve this type of question. 1 2 3 4 5 steps. These are the common steps that we have to use to find out or to solve the question related to the applications of differential equation. Okay, thank you.